Okay. So, the next thing we need to talk about with quadratics is how they move from what we call the parent function. Okay, so every set of equations has what we call the parent function. The parent function of a linear equation. Whoops, I'm stabbing myself with some Sharpie. I'm coloring on myself with Sharpie. So, y equals x is what we call the parent function of a linear. Okay, this goes through the origin and it goes up 1 over 1. Every equation has a parent function. So your parent of a quadratic is x squared. Everything else we add to it changes it somehow. It moves it up, it moves it down, it moves it to the right, to the left, it makes it fat, it makes it skinny, it flips it upside down. Okay. So anything that happens outside of x squared will change what your picture looks like. So this is easily seen from vertex form, which is why we've taught you completing the square, because completing the square can actually be vertex form. Okay, so vertex form. Think about where your numbers are. So a times x minus h squared plus k. Right now, we're trying to figure out what does this do to my equation.
The negative h.
Okay, take a look at what variable it's in. It's inside the parentheses with your what?
X.
X. Which direction does your x-axis go? Left and right. So guess what? This is a horizontal translation, which means it moves it either to the left or to the right. Okay? So think about it that way. If it's with your x, it moves it left and right. Okay? Now, it says when h is positive, the graph shifts to the right. When h is negative, it switches to the left. But before I can do that, so x minus h equals 0, which means this is actually a positive h. Remember, when we factored, we had to set your factors equal to 0. So actually, if I have x minus h, my h value is actually positive because I'd have to move it across that equal sign. So if I have x plus h, my h is actually negative. Okay. My goal by the end of today is I want you to be able to look at an equation and tell me it flips upside down, it moves to the right by 2, up by 3, and it's fat.
It's fat?
Yes.
Is it ever skinny?
Yes, it
can be skinny.
It can be skinny, it can be fat.
Can it be medium?
I mean, medium would be normal.
Oh, okay.
You know.
Can you
So you either have Miss Smith
or
Harley.
Little Harley.
Okay.
Or Tay.
Or Tay. Yes, I'm medium.
Sorry.
Okay.
Tay in the middle, then you got Little Harley over here,
you got
and then you got Miss Smith over here. Fat,
Come on.
No, you guys not fat.
skinny, and normal.
You're lollies. What you say?
Hey, Lotto Miss Smith's side.
No.
I feel like I'm.
Okay. So if we open this up, okay, if we open this up, our regular quadratic, our parent function of x squared, so this one right here, has a point at the origin. Okay, so your regular quadratic starts at the origin. It has a point to the right one and up one. And because this is an axis of symmetry, we also have one to the left and up one. So my parent function looks like this.
I look good.
Thanks, I got skills. I got skills. They're multiplying. And I'm losing control.
Are you?
Okay.
For the power you're supplying.
Wait, why does it start right there? Wait, why does Wait.
That's my parent function. That's my original. We're always going to draw an original. Okay. Number 2, I've changed my function by putting x minus 3 in parentheses now. So in order to figure out which way it moves, we would set this equal to 0. X minus 3 equals 0. That is not showing up very well. I think I need a new color
I put
tag.
them behind it. Get pink. Yellow.
It's not yellow. It's green.
Where do you see green? Oh. Okay, wait. Put it under the light.
The graph? Yes. That's always.
Does it look yellow to you, or does
Yeah, it
look
looks yellow. Okay, so x minus 3 equals 0 means it's going to be positive 3. So that means we move to the right. Okay, so each one of these points moves to the right by 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. So there's my new picture. If I move it to the right by 3, this is what my picture looks like.
Will they only show the new one like on test, or will they show both?
So you might actually just be given an equation and it says like in words what is happening. So like I could give you something like this, and you have to tell me in words what's happening. So right now, all we know is this would move to the right by 4.
Right.
Okay. We'll keep adding to this as we do more.
Oh,
Okay.
that was it.
No. Okay. So if I change it and I put x plus 2 in parentheses, that means x plus 2 equals 0, which is x is negative 2. So this is actually going to move the graph to the left. So it goes 1, 2 to the left, 2 to the left, 2 to the left. My graph now looks like this.
What is parabolas?
I know. Parabolas.
I can't stand these parabolas. No, seriously.
Okay. Which way does 4 take me? 1 to the
Right.
1 to the right. This is actually x equals 1. So it only moves 1 space to the right. Okay. So here's all 4 of them right in a row.
You always do them from the original?
Yes. Always go from the original. Okay.
No.
We're going to show, trust me, I've got it all right here. You're going to see how it changes upside down, how it does all that happy stuff.
That's not gonna happen.
Why?
So,
Sad.
It's sad because we have to learn.
yeah.
Wow.
That sounds about right.
Okay. So my H value, trust me, we all need that break right now. The H value moves my graph left or right. Okay. If I scoochie over, scoochie,
I love when you say that.
Wait a minute.
scoochie,
Coochie, coochie.
Oh,
That's
that's
the last song.
scoochie. Okay. So take a look where your K is. Okay. Your K value is outside of the parentheses. So is it with my X?
No.
No.
Oh,
Which means it affects my Y value. Anything that is outside of the parentheses affects my Y value. Okay, so K is either going to move my graph up or down. Okay, if it's plus K, it moves it up. If it's minus K, it moves it down. So H was opposite of what you saw. So in other words, if I have X minus 4, it moved it opposite. It moved it to the right. But this plus 3 will move it up. So this graph goes up by 3.
And you would do them together and then.
Mhm. So let's open this up. Okay, again, everything starts with our parent function. So we're going to put our parent function on here again. Here's my parent.
Is there a specific reason why that always, why it's always starting right there? Right. I mean, not like right there, but like why those other 2 points are right.
Because your A value is 1. So it's kind of like a slope for your first point to the right one and up one, just like your linear.
So the A is not going to be like anything.
No, I said.
Yeah. We're going to talk about that too. Okay. Okay. Giggles. I understand it's Monday. We've got to get our lives together.
I've had a pretty good there.
I see this. Okay.
Crazy.
So, if I do x squared plus 1, not in parentheses, it moves it up 1. So, this graph looks like this.
Oh my gosh.
Oh my gosh.
So it's like a dilation?
No. No, your A. This is a translation, but it's a vertical translation this time. Okay? Number 3, x squared minus 2. Down by 2. Again, from my original graph. You want to go from your original graph.
Is this the same thing we do like last week?
No. I mean, we're still on quadratics. Okay. Finally, my last one is going to move me where?
Down 4.
Down by 4. Okay, I showed you how to move a graph up and down. I've shown you how to do it left and right. Okay?
And now all the way.
We can reflect a graph. Okay? So I can change my smiley quadratic to a frowny quadratic. Oh, sad little quadratic. Oh. Okay, so if my A value, my x squared value is positive, it stays happy quadratic. If we make it negative, it becomes frowny quadratic. Okay? So, here we go. Okay. Original graph again. 0, 0, 1, 1, and negative 1, 1.
Sorry, you're fine.
They always start in that spot.
Yes.
They do.
Yes. Every parent function will start in that spot.
Like forever and ever and ever always.
Forever and ever and ever and always.
Thanks.
Okay, so number 2, all I did was make my x squared a negative. So now my a value is -1. So instead of happy, we're now getting sad. So these points that are up here have now reflected over my x-axis and gone down here.
Why you put A?
And where'd you get the
Because your a value is what's in front of x squared. Okay, remember, A, B, and C. A is in front of x squared, B is in front of x, and C is by itself.
Okay.
This is A.
No. That's H and K. We're in vertex form, we're not in standard form. But your A value, it will always be the same. It's always the number in front of your x.
You know how like A and C coefficient is always A is always coefficient A
So
squared.
if it's outside like this, it would have a negative or a positive.
Okay, so take a look at number 3. Do we have happy quadratic or sad quadratic?
Sad quadratic.
Confused quadratic.
Confused.
Is my A value negative or positive here?
Positive.
So how are you telling me sad quadratic?
Because y'all want to be sad.
Because it's X equal. You gotta make it X equals.
Yeah, what she said.
I'm just playing. That's
But that's not your A.
See, I'm just playing. I told you.
You know it's positive because there's not a negative in front of the parentheses. Right?
I'm 6.
In
It's a
order
happy
for
quadratic.
it to be sad quadratic, there has to be a negative out front. There is no negative out front, which means my A value is 1. So this parabola opens up. So this is a happy quadratic. However, how does this quadratic move?
To the right one. Oh, it doesn't.
It don't. It just. It don't. It don't.
It goes to the left.
does.
It go up. It go up. It goes down.
There's no
It
left.
goes to the
Okay.
left.
Stop.
To the left, to the left.
Oh, so the right is positive.
Okay. So first off, is the number with my X or without? It's with it. It's inside the parentheses. So that automatically tells me it goes left or it goes to the right.
Right. Left.
It's X plus 1.
So right.
Right.
It's right.
To the left.
It's to the left. No, it's to the left.
Oh, to the left. It is opposite of what is in there. Remember, when it's
Oh, because the X. I told you the X equals. You gotta do 0. That hurts. Okay, shut up. Shut up. Shut up.
I mean, since y'all are experts, I can just let it go, right?
No, don't.
Okay,
make-
shut up. Pay attention. Okay, so it moves it to the left. Anything in parentheses has to be set equal to 0 to get the true value. So while you automatically think X plus 1 is positive, when I set it equal to 0, it actually becomes -1, which moves it to the left. So it's staying face up and it's moving to the left by 1. So each one of these dots moves to the left by 1 and it stays face up. You'll be all right for this last example if you can get that back real fast.
Oh, okay.
Yeah. Okay, take a look at this last one. Okay, take a look at this last one. Is there a negative out front?
Yep.
Yes. So that means my happy face turns into a sad face. So this tells me it goes down. A is -1, so it's a frown. Okay. What did we say that x plus 1 does?
It's -1.
It's -1, so it moves to the left by 1. Okay, so not only does my graph move to the left by 1, but now instead of it facing up, my points are facing down. So this graph will look like this. Okay, worst comes to worst. If you can't look at this and identify, however, I want you to try today. Come testing time, if they say, how does this graph move? Plug it in your calculator and see how it moves.
Got you.
Oh!
Say
I'm
it one more
definitely
time.
gonna do that.
Okay, so in other words, if I'm looking at a graph, let's say that I give you the equation y equals x plus 3 squared minus 4. Okay? And you're sitting there looking at this and going, I don't know, I don't know, I don't know. But if you plug this into y equals, and your graph pops up like this, how did I move from this origin? To the left and down.
To the left. Oh my God.
Yes.
Shut up.
This one's still up because
I guess it's the
I
purpose. That's why I said
when I changed my A value to a negative, not only did it move it over, and then it flipped it upside down. So you go over 1, and then it's being reflected over your x.
You
So
had to
this is
take
1
it.
above the x, it goes 1 below the x. Your x is your axis of or your line of reflection, and then reflects down. Yes.
If you say left, it's
It reflects. It doesn't go down 1. It reflects over it. So remember when we did reflection?
not gonna happen.
If this was my line of reflection, and I had a point that was 5 spaces up, my new point had to be 5 spaces down. That's the same thing here. So this point was originally 1 space up, so it now needs to go 1 space below. This is 1 space up, it goes 1 space.
You don't call me beautiful anymore, so I can't call you beautiful. Hey, beautiful.
That's your point. So like this was your original point. This is your original graph. When I just make it negative, it reflects over. So if it takes 1 space to get here, it takes 1 space to my negative 1 space to get here, 1 space to my negative 1. Because this was on the x-axis, it doesn't.
Oh.
Does that make sense?
Yeah.
Right. And then the other one, you move it over before you do that.
So in other words,
You're technically reflecting it.
because he said he was ghost,
Except
right?
this one's at the origin and this one is to the left.
This is my pen.
Oh my God. Oh my God.
Yes. No. This is stuck to origin, this is shifted to the left.
Might have been even funnier.
So this last picture. So it shifted to the left and became this. and then it's not close up right here.
And then just stop like up there.
So you had two things that happened. You had to move it left, and then you had to run left.
Oh, this part.
And she messed up her own. Everything that we've done so far is not fair. Because you have that plus one there that tells you that it has to move to the left.
That one still chicken was from Walmart.
I'm going. I gotta get that ranch. I gotta get ranch.
Nothing.
But that's not fair. You just gotta eat it deer.
The only way we go
No,
down
they
is
had
to
pizza.
the outside.
Ask for buckets.
That's what left.
Oh, yeah. Yeah, well, it took a couple hours. That's why she was thinking, I'm gonna go back for it now.
What the? Bro, this. Oh.
All right. Okay. Ladies and gents, this is the last one we need to talk about. Okay. This is now a dilation. When we did dilations in Unit 1, what did that do to my picture?
It made it bigger or smaller?
Bigger or smaller? Guess what?
What?
That's what it's going to do to your quadratic. Okay, so we call this fat norm because you're going to make your graph nice and wide and fat, or we call this skinny norm. You're going to stretch it up and make it skinny.
That's Abby. Tall and skinny.
Tall and skinny.
What?
Oh my goodness.
More skinny to take that.
All right. So here we go. Breathe. Okay. Again, here's your original picture. Does it? I'm so glad. I'm glad I can make you happy. Loloro? Loloro? It's a company.
My dad shops at Megdra. I hate that store.
Okay.
You guys get stuff from there?
Squared. What is my A value?
2.
A is 2. So that means we've got a vertical stretch. We have a vertical stretch.
What is that?
Okay, so first off, is it inside the parentheses?
No.
No.
Like,
You don't see any parentheses.
I was about to say,
Okay,
we also
so
I'm just joking.
I was looking at the second one.
the second one's in parentheses, but it's still not in parentheses with your X. So be careful with that. Okay, so it is not in parentheses with my X. Therefore, it affects my Y, which is why it's vertical. This affects,
You can think about it as a relationship.
yes, as I'm throwing stuff.
Like, if it's in there with your ex, is that gonna move you forward with them or back with them?
I mean, listen, if that works for you, Teron, rock it. Okay, so because it's not in parentheses with your X, we call this a vertical stretch. Well, if I'm stretching something vertically, is it getting skinnier or fatter? Fatter.
Better.
Oh, wait, skinnier. If I grab you by your hair and step on your feet and stretch, you're gonna get skinnier.
Just a little bit.
So this is skinny. Okay, so what happens here? Okay, we've not moved left, we've not moved right, we've not moved up, we've not moved down. We have just made this skinnier. So instead of going to the left one and up one, now I'm going to the left one and up 2.
You said left, but you went right.
or I'm sorry, right 1 and up 1, or up 2. Goodness gracious. Okay, so instead of going right 1 and up 1, I'm going right 1 and up 2 because my A value is 2. What happens on the right-hand side also happens on the left.
Yes.
Okay.
You know what I'm laughing about. Shut up. I'm sorry.
Okay. Take a look at number 3. Okay. Be very careful. 1/2 is in parentheses, but is it in parentheses with your X?
No.
No. So this still affects my Y. This still affects my Y. So my A value this time is 1/2, which means this is called a vertical compression. Compression. Okay. When I'm compressing, I'm pushing down. If I take Bobo by the head, you know, tall man Bobo, and I push him down to the
I
ground,
tried to do that before. You don't let me.
what's going to happen to Bobo?
You're gonna
He's
get
gonna
I
get
still want you to get
fat. So, a vertical compression makes my graph fat. Fat. Oompa loompa.
Okay, y'all.
We call it fat norm and skinny norm. And we call it norm because normal. So this is fatter than normal, skinnier than normal. Okay. Take a look at your A value. This is how we find your first point from the origin. My A is 1/2. So just like a slope, but you can only do this with 1 point. So this means I go up 1 and to the right by 2.
Stop.
What happens on the right side of the graph also happens on the left because we have that axis of symmetry.
Stop.
Stop.
You keep putting cotton in my ears.
Up 1 to the right 2. What happens on the right has to happen on the left because you have that axis of symmetry. So it needs to be folded in half and should lie on top of each other.
So one, that's a half. That's not.
Huh?
Why have to do it? It's a half.
What do you mean it's a half?
One.
Yes.
Why you have to go up one?
So if I told you that your slope of a linear line, let's say I give you y equals 2x plus 3. That means you start at 3 and you go up 2 into the right 1, up 2 into the right 1 to graph your, okay? That's basically what you do here. So from the origin, my slope or my A value is telling me to go up 1 into the right by 2. Okay, so if you look at the other one, my A value was 2, which means my slope is technically 2/1, which means I go up 2 into the right 1. So I went up 2 into the right 1. Okay, let me make up another one here. Okay, let's do 4x squared. Y equals 4x squared. So, is this a vertical stretch or compression? Stretch. This is a vertical stretch. Okay, my A value is 4. So technically it's 4 over 1. Okay, just remember, this is only good for 1 point. You cannot keep using the slope over and over and over again. This is a quadratic, not a linear. So you can only use this for 1 point. So my first point from my origin is going up by 4 because it's positive and to the right by 1. So it goes 1, 2, 3, 4 and to the right. What happens on the right-hand side also happens on the left.
So you don't always have the middle.
Yes, you always have an axis of symmetry with your quadratic. So 4 makes it even skinnier. The bigger your A value is, the skinnier that your graph gets. Okay, so if I make it a 16, it's really skinny. Okay, because it kind of shoots straight up and then over by 1. Okay, let's do 1/5. Y equals 1/5 x squared. Okay, so this is a vertical compression. And it goes up 1 and to the right by 5. What happens on the right happens on the left.
Wait, are you supposed to put parentheses on that?
No, it doesn't matter whether it's in parentheses or not, as long as it's not with the x. Okay, look how fat that one got. That one's like mega fat.
That is mega
Bobo's
fat.
head.
Mega fat off Bobo's head.
Your nose. Bruh, that's what I'm saying.
That's his
Bobo,
feet.
right. Your big ridiculous feet now.
Oh my goodness.
Alligators for your feet.
Okay.
We already talked about
The last thing we did not talk about is how we horizontally stretch or compress. Okay, think about it. Horizontal stretch
It goes
make it fat. It's going to be the same thing as a vertical what?
compression.
Compression.
Oh my god.
Okay, so I can also write a vertical compression. That's
It's not right.
horizontal stretch.
See, you are out of your mind.
So would that be yeah.
So you said a vertical compression is the same thing as a.
So would that be the H?
So this is a horizontal stretch.
So is a vertical stretch the same thing as a horizontal compression?
Absolutely.
Wait,
So-
what did you say? A horizontal compression is the same thing as a vertical stretch, and a vertical stretch is the same thing as a horizontal compression.
So with it being in parentheses with the X, that makes it H.
Yes. Because the X goes horizontal, so it's horizontal when you're dealing with it. Absolutely. So notice, Lolly just said, with that being inside the parentheses with my X, that's why it moves horizontally. My X moves horizontally. That's why this is called a horizontal stretch. Okay, and again, if I'm stretching horizontally, that's the same thing as me compressing vertically.
Period.
Okay, so I can also do 3x squared, and this is a vertical stretch, or we would call this a horizontal compression.
So is this all we
Veggie pizza. Veggie pizza out of all the pizza.
It's not in
This is why you're not comprehending or understanding, because you're worried about pizza and everything else. So I have no sympathy at this point. Okay. So again, vertical stretch is the same thing as me shoving you all together.
Oh my.
Okay. Pushing you down is the same thing as you spreading out wide. So horizontal stretch, push down.
So it's like Play-Doh. Like, you know how you push it
And it washes out. Or if you pull it and stretch it, it makes it tall and skinny. There you go. Okay. Questions? Okay.
Is this just the beginning of this? Or
This is it.
That's it?
That's it. And guess what? Can I just tell you this?
Yes.
All these rules you just learned for transforming quadratics, this will work in the next unit when we transform radicals. This will work in Math 3 when you transform absolute values.
Oh my God.
All of these are the same. Okay, before we glue in, I want to go through these ones. Okay, I'm only doing the front page with you. The other 2 pages I want you to do before you start your homework.
Before we start.
Yes.
So crazy.
I'm crazy today. I know. Because this is matching.
You're crazy.
I mean, technically,
Oh,
you're
it's matching?
Okay.
You know what? I think someone calling
So-
Miss Smith, you took my paper. Who calling me?
Hello?
My audio don't work. You got to turn.
Oh. You gotta turn on speaker. Hello? Oh my God. Is that Giselle? Yeah, hello? Hello, Giselle. She's in class right now. Can we call you back? What?
Wow. He only 18. I mean, 19.
I'm
What's up?
try these.
Post on my story.
Woo!
I'll play it. Yes, I was
She's coming up here, Ted. All right. Take a look at A. How is the equation A moving? X squared minus 2. Think about where your negative 2 is
It's going down to
and which way it moves. Down 2. This one moves down by 2. So this is number 9 is A. Okay. B. X plus 3 squared.
down to left by 2. Down by 2. Down 3.
Three.
I meant the number 3.
Left
3.
3. I was trying to figure out where you're coming up with 2.
You know
That's B. B is 1.
Yeah.
Left
We got that.
is B is 1.
We have to do that.
Right? You have to do me like that, huh?
Okay. C.
To the right one.
No.
Up one.
Up 1.
That's what I thought, but then I thought I was wrong.
Kelly, she wants you.
So that is C.
Down
C
3.
is 10.
10 is down 3. D is down 3.
D is down by 3.
3. No.
So D is number 3.
E is to the left. 4. I meant to the right. It's for you.
Okay. E is to the right by 3. So that is 17. Okay. F.
14.
Up by 3. And that's 14. Okay. G.
8. Right. 5.
Right 5. And that's 8. H.
Up 5.
Up 5. So that's number 2.
To the right 4.
To the right by 4. Go
That's
Kenley.
I. I mean,
So that's
13.
13 is I.
Down by 5, J.
Down by 5 is J.
7. I'm sorry. I really am trying to.
Okay. K.
Left 2, number 5.
Left 2, number 5. I'm sorry, L.
Left 5, number 11.
Left 5, number 11. M.
Up 2, number 18.
Up 2, number 18.
Down 4, number 16.
Down 4, number 16.
To the left 4.
To the left 4.
16.
To the left 1.
Number 12.
And that's P. To the right by 2.
4.
And that's Q.
And then R is
6.
4, number 6. Oh my gosh, I actually don't
Okay.
know.
So, as always, the first activity is the easy one.
Oh, of course.
As you move on,
Oh my. Follow.
okay? So,
Oh my god.
exercise number 2 adds in your vertical stretches, your vertical compressions, your horizontal stretches, your horizontal compressions, okay? It's just one transformation per equation, though. And then when you move on to the right-hand side, you have more than one thing happening. So, let's pick one on activity 3 to do together.
G. Letter I.
Letter I.
Letter I. Number I.
Okay. Actually, let's do
J. H.
H.
Yeah.
Let's do H. Okay. So, somebody tell me what this 4 does.
Nothing. That's what we're starting.
Up 4.
Oh.
Okay. So, this goes up 4. What does that 3 do?
To the left 3.
To the left 3.
Oh, yeah.
Okay. 2. Am I dealing with vertical or horizontal?
Horizontal.
Vertical. Remember, it's horizontal if it's inside the parentheses with the X. It's outside, which means it's dealing Y, so it's talking vertical. Is this a vertical stretch or compression? Stretch. This is a vertical stretch by 2. So, vertical stretch by 2, left 3, up 4. That's 15. So that's H.
How do we know if it's stretch or compression?
Yeah.
Your whether it's greater than 1 is a stretch vertically, compression horizontally. If it's a fraction, it's a vertical compression, horizontal stretch. Okay, so you always want to refer back to, is this one mine or yours?
Mine.
Okay, well, I'm going to steal it anyway.
Okay.
So you always want to refer back to this front page. Okay, so when your A value is greater than 1, it's stretched vertically, which means it's a horizontal, I guess we should put this on here, horizontal compression. Okay. And then if it's between 0 and 1, so if it's a fraction, it's stretched horizontally or a vertical compression.
Excuse me, that's on the other piece of paper?
Yeah, it's on the front side of the other piece of paper.
I didn't even finish the front.
Okay.
Okay, so no, it's too dark.
Where is it at?
It's on. It's right here.
Okay, so this is.
That's the same thing as a horizontal compression. Okay. Yes.
It's B. Can you come here?
Is there any more that you wrote down like that? That's on this piece of paper? Okay, so
I
how do we
just
know
added
if
that
it's only horizontal and vertical compression?
Mhm.
That's it.
I got a question.
Well, it's a vertical stretch or a horizontal compression. And this is a horizontal stretch or a vertical compression.
Okay, horizontal.
So think about it. If you're stretching vertically, I'm squeezing you horizonally. And if I'm pushing you down vertically, you're stretching horizontally.
I got a
So,
question.
do you look at some, 98.99?
What determines if it opens to the X or the Y?
Huh?
What determines if it opens towards the X or the Y axis?
What do you mean opens towards the X or the Y axis? I don't know what that means. The negative. And yeah, if it's negative on the outside, it reflects over your X. If it's negative on the inside, it reflects over your Y.
That's what I'm saying.
Okay, so what I want you to do is the first page we did glues in on page 98. This one will glue in on page 99. When you are done with exercise 2, if you'd like me to check it first before you move on to exercise 3, that is fine. Okay, if you want to wait till you're completely finished and let me check it, that is fine as well. And I do have a homework assignment.